Welcome back to the 10th video in the Pearson Geometry series. Section 2.2 on proving parallel lines uses the converses of previous theorems to prove lines are parallel. In the last section, we had a number of theorems that, with parallel lines cut by a transversal, meant that either the angles were congruent or they were supplementary. Now we're going to turn that around, and if they are congruent or supplementary, we're going to say that the lines are parallel. So the first one that we have is the converse of the corresponding angles theorem. This one says if two corresponding angles are congruent, then the lines are parallel. So if two corresponding angles are congruent, then the lines are parallel. Okay, a second one is the converse of the alternate interior angles theorem. And like the other one, this one says if two alternate interior angles are congruent, then the lines are parallel. So if two alternate interior angles are congruent, then the lines are parallel. Okay, now let's talk about a proof that looks a lot like a flowchart. This is called a flow proof. Before starting, I'm adding a diagram to it. You'll need to add this to your notes because without the diagram, the flow proof itself doesn't make much sense. Okay, also with a flow proof, the statements go inside the boxes and the reasons go underneath the boxes. So here's what we're going to start with. We have a given of angle 1 is congruent to angle 2. So we write that inside the box, and then underneath it, we write given. Okay, now let's go look at our diagram. Over here with our diagram, whoops, let's put another angle right here. Okay, over here with our diagram, we have angle 1 and 2, which are congruent, but we also have angle 1 and 3. Those are also congruent. Do you remember why? So we're going to put angle 1 is congruent to angle 3. And if you remembered that those are congruent because they're vertical angles, then you are absolutely right. Vertical angles are always congruent. Okay, now we are now showing that angle 3 and angle 2 are congruent. So looking back at what we already have, we have angle 2 congruent to angle 1 and angle 3 congruent to angle 1. And if you remember using the transitive property, we can cancel out the ones that are the same and say angle 2 is congruent to angle 3. And that's going to be the transitive property. There are two of them, transitive property of equality and transitive property of congruence. And since we're working with congruent statements, we're going to say transitive property of congruence. Okay, going back to our diagram, we have two corresponding angles, and they are marked congruent. So we can say that line L is parallel to line M because two congruent corresponding angles mean that using the converse of the corresponding angles theorem, we can say that those are parallel. So converse of corresponding angles theorem. Okay, and that is your first flow proof. All right, go ahead and flip this over. We've got two more converses here, very similar to the ones on the other side. These two are not congruent. It says if the measure of angle 1 plus measure of angle 2 equals 180. So if those are supplementary and they are same side anterior angles, then the two lines are parallel. So if two same side interior angles, if two same side interior angles are supplementary, then the lines are parallel. Okay, and the last one, the converse of the alternate exterior angles theorem. I have two congruent alternate exterior angles. If my two alternate exterior angles are congruent, then the lines are parallel. So if two alternate exterior angles are congruent, then the lines are parallel. Okay, two more theorems and we're finished. So theorem 2.8. I'm going to draw you a picture first. Okay, one line, two lines, and three lines. And I'm going to make these two lines parallel. Remember the hooks that were the triangles or the arrows that we used yesterday? And I'm going to make these two lines parallel. Okay, so these two are parallel with one arrow. These two are parallel with two arrows. And theorem 2.8 says if two lines are parallel to the same line, then those two lines are parallel. Okay, if two lines are parallel to the same line, then the two lines are parallel. And that's parallel to each other. Okay, theorem 2.9 is similar. Okay, so we've got two lines that are perpendicular to the same line. So this line is perpendicular to this one, and this line is perpendicular to this one. So we can say if two lines are perpendicular to the same line, two lines are perpendicular to the same line, then the two lines are parallel. Okay, so that about wraps that up. I will catch you on the flip side. See ya.